right. Well, hey, everyone. I'm Shannon Keebler, and I'm so excited to be with you today. We're talking about how to talk to students about math, what to say, what not to say, and how we can make the most out of the minutes that we have with students. So I'm going to share a screen here so that you can follow along with our ideas for today, because the way that we talk about math, we know that this matters, right? So here's a few things that I want us to think about as we are talking to students about math. Here's what I want you not to say. Number one, it was bad at math. We don't want to say that. We don't want our parents to say that. We want to get that out of our vocabulary. So we were never bad at math. We didn't understand things. We may not have gotten the right answers. We may not have understood the first time, but it doesn't mean we were bad at it. And that also gives that idea that it's okay. Like, you're bad at math. I was bad at math. Okay, nope, that's not the case. We didn't understand what we were doing, and we may have struggled, but because we struggled does not mean that we're bad at it. And that's probably a really important key understanding in terms of we've equated struggle to mean bad, and that's not true. Right? So just because you struggle doesn't mean that you're bad at it. In fact, there's a really interesting study out of Stanford about women in the math field specifically that are dropping out of math majors after they enter Stanford, their first, I think it's like after their first semester, first year, okay, and they're changing their major. Why? It's because they didn't really struggle with math until they went to higher level in college. And then when they get to college, they start to struggle a little bit. It's not as simple for them. And they've equated that, wait a minute, I've never struggled before. And the fact that I'm struggling now must mean I'm not actually cut out for this. I'm not as good at this as I thought I was, which is not true, right? So we want to make sure that students are encountering struggle along the way, and they know that struggle is a part of learning. And that it's through that struggle that we grow and we become better mathematicians. But struggle does not mean that we're bad. The other thing that we want to resist saying to our students is we want to resist saying, you should have learned this. Okay, so this comes in really very often when we're talking about math facts. We're trying to do something like, let's say, long division, and we say, okay, so 6 times what equals 48? And kids just like stare at you. And you're like, oh, guys, you were supposed to already know this. Like, why don't you already know this? You were supposed to learn this in 3rd grade, or fill in the blank. So we don't intend to cause shame, but that is a very shaming statement. So we're saying, you don't know, and you should. And how helpful is that? So when I say, hey, I can't figure out how to turn on my TV or to get to the right streaming service, a common issue for myself, and my husband may say, you should already know this. I've already taught you this. Does that help me to do what I need to do in terms of finding the right service or turning on the TV? It doesn't. In fact, it just makes me feel bad that I'm supposed to know it and I don't, but it doesn't help me to know it anymore. So instead of saying, hey, you should have learned this, I'm going to give you some other things that you might say here in just a moment. But it's shaming, right? And when we shame students, what ends up happening is we put pressure on our hippocampus. And our hippocampus is the part of our working memory that controls our working memory. So once we put pressure on that part of our brain, it shuts down our working memory. So even if we were to recollect or retrieve that information, and like, you're right, we did learn this, and go into those stores to pull it out, I'm not going to now. So even if I used to know 6 times what equaled 48, I have so much pressure on that hippocampus now, I'm not coming up with that math fact, even if I did know it, right? The next thing I want you to resist saying to your students is this. I want you to resist saying, you don't know, fill in the blank. Okay, similar to what we just said with, you should have learned this. So you don't know how to add that? You don't know how to divide? You don't know how to make a picture of that? Like, we're shocked, right? And the problem with, you should have learned this, it comes from a really genuine and unintentionally harming way, right? Meaning we're not trying to harm students with it, but we're frustrated because we're trying to move forward with our standards and we can't because they don't have prerequisite skills. And now we're just frustrated. So the statements come out of frustration, which is justifiably so, right? Like, we understand why we might say that. The same thing with, you don't know, because we're shocked. We're like, wait a minute, you're supposed to know this. Okay, it's supposed to, you should have learned this. It has the exact same same results as you should have learned this in. Okay. So it doesn't help that I should know it. It doesn't help that I don't know it. Like, I just need your help in keeping me in the conversation and keeping me in the learning so that the learning moves forward. So those are some three things, okay, that we're going to assume that are impacting students negatively, because we know that is to be true. And what could we do instead? So now, if you've said any of those things, it's okay. I've said them too. I still catch myself saying things like that when I'm in the middle of a lesson. I feel like I'm getting momentum and something happens and I'm like, oh my gosh, you guys don't know that? Okay, you're supposed to know that. And I catch myself. So even if you have said those things in the past, or you are saying those things and you don't mean to say those things, we are human. I want to give you some grace of, we do better when we know better. But just because we know better doesn't mean we're going to be perfect. We are still going to say things that may unintentionally be harmful to students. But awareness, as we know, is the first step. So instead of feeling guilty about it, let's just equip ourselves with other one-liners or other things that we can say in the place of those statements. So instead of saying those, I'd like for you to say things like this. I don't get it the first time either. So instead of saying, I'm bad at math, I might say, yeah, I don't always get it the first time either. And when I first learned this, I wasn't sure how to work with it. Like fractions for me. Fractions were not easy for me when I first learned fractions in 5th grade. Okay, I remember explicitly those times having my mom try to teach me with egg cartons. And I was like, this is like a foreign language. I do not understand it. So empathizing is a way of connecting. I know how you feel. It was hard for me too, right? Or I don't get it always the first time either. We're saying we know what it's like to struggle. And I think sometimes our students think that because we're teachers, we're just really good at it. And we just have always known it. And I think that's kind of why we say like, hey, I was bad at math too. Don't feel bad. But that statement of I was bad at math too isn't actually helping move us forward. So instead, we're going to say, hey, I didn't get it the first time either. Next thing, let me remind you what you know, or what do you know? So instead of saying, you should have learned this in, I might say, okay, so let me remind you what you did in 3rd grade. And I'm going to start to help make those connections, right, to learning that we've already had. We know that connections are one of the most important things that we do in teaching. Like I usually say, I think it's like 90% of what we're doing is just making connections. So instead of assuming that they should know or asking them, what do you remember about this? Which I could still do. I'm saying, let me remind you what we did in 3rd grade. Okay. So a really good example was I was recently teaching 5th grade multiplying mixed numbers. Okay. No joke, not an easy thing, but we're supposed to do it with the area model. And they specifically in their standards, it says you have to do the area model by tiling for this 5th grade standard. So we don't have a choice but to do the area model. We can't just teach them a shortcut method. So I'm trying to connect it to students, not ever having taught this students before. And I said, let me remind you what we did in 3rd grade. And I drew a regular area model. I said, so what if I did by a 3x4? What would you know? And we did 3 rows by 4 columns, right? And we put the squares inside. And kids are like, well, it's just 3 times 4 equals 12. We could count the squares, or we could do a multiplication equation. You're right. We did that. Okay. Look what we did then in 4th grade. And I said, I did double digit, like 22 times 17. And I showed them how we did the area model when it was 4th grade. And kids like, yeah, I remember doing that. Okay, perfect. Let's see what we did in 5th grade just like a couple weeks ago. Remember when we did a fraction of a fraction? I did an area model. I showed them. I'm like, so look what we did in 3rd grade. It was right underneath. And this is how it went in 5th grade. Okay, so you see how they're similar? So this is what we did in 4th grade with double digits. Now let me show you, instead of a double digit, we're going to do with mixed numbers. I want to show you, you already know so much of this. I'm just going to show you the new part we're adding on or how we're changing it. So I didn't assume that they were just going to recollect it. I prompted, I front loaded and said, let me remind you where we're coming from. It took less than 5 minutes just to say, do you remember doing this? What did we do? Do you remember doing this? And I accompanied it by visuals. So I said that, let me remind you what you know. Okay. The next thing I would ask students is, well, what do you know? So if they said, well, I don't know what times 6 equals 48, right? And I'm like, oh my gosh, you guys should know this. Why don't you know this? Instead, I'm going to say, what do you know? Okay, great. So you don't remember with 6 times what equals 48. No problem. I forget sometimes too. What do you know? So if you don't know 6 groups of 8, do you know 5 groups of 8? That keeps them in the game. It keeps them learning and it keeps them moving forward versus you don't know. Oh my gosh, guys, how am I supposed to do this? You're supposed to be practicing your math facts. I mean, let's go on and on and on and on. Okay. So instead I'm just saying, well, just tell me what you do know then. Does it take extra time? Yeah. But does it keep the learning going forward? Yes. Is it less shameful? Absolutely. I need students to start to see themselves in a very positive light, and that just because you don't know it now or you don't remember doesn't mean you're incapable of learning, okay, or that you are bad at math. So let's move forward here to a few other things you can do. Okay, so if your students then makes a mistake, here's some other things we can do. Okay, the 3 C's. So I really like the 3 C's from Kathy Fosnot. The 3 C's are this: celebrate, clarify, challenge. Okay, celebrate. So when I see the students did something, I know we often say like don't tell kids that they're wrong. And I know that comes across like, of course they're wrong. Yeah, I want them to know that's not correct. But when I say, no, guys, that's not how we do it, you're supposed to, or no, anyone else? Okay, it doesn't mean that I'm not telling them they're wrong. It's how I'm doing that. So in this case, I see something, I'm like, man, I really love that this mathematician knew that they were supposed to draw a picture, right? So just recently I did another demo lesson and we pulled up some boards, and their boards weren't using, it was multiplying a fraction of a fraction actually, and they weren't correct. Like I just prompted a problem and said, hey, I want you to try, what do you think you would do with this? Okay, and I wanted them to say do what they would intuitively do without instruction yet. So how would you solve this particular problem? And kids were really trying. I said, I want a picture, and then you can write an equation. Well, their pictures were showing me that they were really trying to make sense of taking a fraction of a fraction. So when I pull up their boards, I'm showing work that is not correct. And I'm saying this person isn't quite there. Okay, but let me show you what I understand. I know that they're doing a picture, and can you see the hole? And I know that they knew to put it in force. Like this person understood what part we had. And this person knew we were talking just about this half. Can you tell how and how they circled it? Now, I want to clarify. I'm wondering why or to a student, why you chose to pull that one piece out over here. Like, what were you thinking? Okay. Or I'm wondering why you put a 0 at that end of that number. Or I'm wondering why, first celebrate. I just point out, hey, I love that you started this. I love that you knew where to line the numbers up. I love that you knew where to put that decimal point. I love that you knew how to draw that one. Like, let's say, first grade, pesky pairs. Okay, oh my gosh, those are hard. Pesky pairs are something like 13 and 30, right? Really difficult numbers because they sound very similar. So they're trying to write 30, but let's just say they write 13 or vice versa. I'm going to celebrate. And so I love that you knew that there was a 3 in this number, or that there was supposed to be a 3 and a 1, or whatever it might be. Okay, I love that you knew that. I'm going to clarify. So tell me again what number you think you're building. See if they can say it. Okay, tell me, like, I'm clarifying. So I celebrate what I see that's correct. Then I clarify and say, so tell me more about. Instead of assuming, yeah, but you got this part wrong. Okay, I'm clarifying. So recently a group of third graders, they're drawing some pictures about some story problems. And the model that they used, let's just say it was equal shares. It was not an equal shares problem. Let's say it was an array problem. Okay, so when I look at their problem, I'm saying, like, celebrating. Okay, what did I see that I liked? I know that you knew the total was 30. I can tell that you knew that there was going to be 4 groups, right? Like, great work, like getting started right away at this. I'm wondering, and I could then fill in the blank. Or I said to them, so the story that your picture is telling me is that you think that there is 3 groups shared with it, 4 brothers. Let's just say something like that. And the kid's like, that's not what I think. I'm like, okay, so why don't you tell me what you think, what your picture is telling? That's clarification. I don't know what you meant. I'm trying to help. And I'm trying to figure out, like, is that true? Because sometimes kids say stuff and they're like, no, that's not what I meant. I was actually thinking XYZ. And I'm like, oh, yeah, you're right then. That totally makes sense. Okay, so I don't want to assume that what I'm interpreting their work at is what they meant, or that it's just wrong, because it's not how I would have done it. I want to clarify. Tell me more about fill in the blank. And when I ask them to tell me more, I actually learn a lot about what they're thinking and what they actually understand. So now I can move to the next C, which is challenge. Oh, so you did think that was the number of groups and that's how much we are sharing. Okay, so here's what I want you to think about. I want you to think about the types of problems that we're working in. And if it's equal groups, equal shares, if we're planting in rows and columns, like, which one do you think? She's like, well, I think it's actually rows and columns. Okay, so I'm challenging you to see how would your picture change if that's true. Or remember, you said that you knew that our fraction had to be getting smaller. So did your fraction get smaller? They're like, no. Okay, so what I'm challenging you is, how would your picture change to show that your fraction's getting smaller? Or what would you need to change in your work to show XYZ? Or you just said you knew you had to have, okay, do you see the point? So celebrate, clarify, and then challenge. All right, other things you can do when students are making mistakes. Another thing you might do is notice and wonder. Okay, so I'm noticing this is very similar to the clarify and challenge. I noticed that you did X, Y, Z. I noticed this about your work. I'm wondering about this part. Tell me more. Okay, another thing is to reflect and revise. So reflect and revise is probably one of my favorites. I really like to think about math in terms of rough drafts, and that this was just your first draft. So head back to your seat, and I want you to try, okay, putting your numbers in order from 1 to 10. I want you to try, the counting on method, do a math mountain and do your circle drawing, whatever it is. Okay, go try it. Then I noticed things. So recently I was in a first grade classroom. I noticed that many first graders were putting boxes for everything that was unknown, right, in their equation. And so I noticed that. Tell me more about why you have a box everywhere. And they're like, well, just because there's, it's a total and a partner and a partner. I said, well, so does the story not tell you 3 things? You don't know the total in the story, you don't know a partner, and you don't know the other partner. You don't really have any information. I'm like, no, we knew the total. No, we knew an unknown. I'm like, but the box is telling me that we didn't know it. Okay, so reflect and revise means, so what might you change now that you know that we only put a box for what's unknown? And like, oh, I think I have to go erase the boxes around the total and the other partner. Right. So why don't you go revise? Okay, so friends, go back to your desks. I want you to remember these things. Remember, we talked about how you have to have this, and this. Remember, we said that we should always check our work for this, right? I'm giving some teaching points based on what I saw them do. I'm being explicit. I'm giving instructional strategies. And then I'm saying, now go revise your thinking. I don't give them even a new problem. I'm saying you already started the problem. So it sounds like a lot of us, as we started it, now we've changed our mind, go reflect and revise. That teaches them we don't get it the first time. Often, I'm not looking for the right answer the first time. I'm looking for effort. I'm looking for you to start. That's what I'm looking for. Once I see you start and try something, I'm teaching you, you can trust your intuition. You are a mathematician. Just start. Then I'm going to reflect, notice, wonder, and then instruct explicitly. I'm going to teach them what they actually have to do or why something doesn't work if they don't know. And then I'm going to give them an opportunity to go revise. Then we go to the next problem. Okay. And we continue to do that. And so that keeps the learning open and it keeps it reflective. So as you're looking at these things, don't forget to use Puzzled Penguin regularly, right? That's what he's for. Let's reflect on Puzzled Penguin. What do you notice about what he did? What do you wonder? What questions could you ask? Let's celebrate. What does Puzzled Penguin doing right? Okay. How can I clarify what he's needing to do? What would you challenge him with? What would he need to go revise next? So in just saying it's wrong, he should erase all of his work, that's never true. There's only a part of his work he's not understanding. So use the exact same strategies with Puzzle Penguin that will not only help you get your language better, but it's teaching students how to respond and interact when someone does make a mistake. All right, friends. So take a look here about thinking about math positively. When we do it this way, we build a positive classroom culture. We build a culture where it's not just about right answers. It's about effort. It's about revising our thinking. It's about the journey. Students view themselves as mathematicians. Mathematicians don't get the answer right the first time, every time. And if they are, then we're not asking the right questions. We're not leaving it open-ended enough. We're just directly telling them what to do. They're regurgitating it, but it doesn't mean they're thinking. Learning is viewed as a journey, not a destination. So learning takes time. Learning involves struggling. It's not just about the right answer. And if your students are obsessed with the right answer, it means we have fostered a classroom that is about the right answer. We've asked them to complete 1 million problems on our workbook page. We've celebrated when they finish, when they turn something in and they get to do something else. Okay. We've told them, hey, just like, oh, all your boards, like, oh, yep, you got it. Yep, you got it. Yep, you got it. Which really means just copy your neighbor so the teacher can say, yep, you got it. Because she's just looking to see who has it right. She's not necessarily looking to see who understands. So we fostered that environment, and that's what we have to work on, is creating a classroom culture that is about math positivity. This is what being a mathematician really means, and how can I keep you learning and moving forward? All right, my friends, those are your next steps. Go try one of those strategies, the 3 C's, notice and wonder, reflect and revise, and then try those new statements that we talked about, which were, I don't get it right the first time either, or I didn't understand the first time I did this, or I struggled with fractions too. Now I know, okay? Or it took me a few times to try this. Let me remind you what you know. Well, if you don't know this, what do you know? Those are really powerful statements. So my friends, I wish you the best as you work on this, as you are working with students in your math classroom. I'd love to know what you think and what strategies you're trying in your classroom. Thanks so much for your time today. I'll see you next time. Bye for now.